Today, 4.2, we are going to be talking about reflections. And a reflection is just basically you take an original image, any image it could be. So let's say we had a cat. We had a cat. Not a great cat, but a cat nonetheless. And we'll make that cat. Let's see here. What color we want to make that cat? Other colors? Yeah, we want to make the cat orange. Let's call that cat orange. We have an orange cat. Like so, we'll color this cat orange. So this is our image of the cat. And with a reflection, I want to, the cat gets flipped over a line of reflection. So let's draw a line of reflection here. This is our line, this blue line of reflection. So I'm gonna take this image and we're going to copy this cat first. So let's do that. Let's copy the cat. That is not how we want to copy the cat. Copy the cat like so, and then we want to flip that cat. So let's flip it. So I want to flip it over the line, and we want to have the cat equidistant from the line of reflection. So our image, our original image, we'll call that M. Our new image, we'll call that M prime, is always equidistant over the line of reflection. It's the exact same image. We flip it over the line of reflection to get the new image. So let's try some other examples. So let's say we had, move this up, we had a triangle. Let's say we have a triangle here. And we'll call this triangle, we'll put this triangle, let's start here, over here, and over here. So this is our triangle, like so. It is 4 on the base and 3 up high. And we'll call this original triangle M. And we want to reflect this triangle. Let's start with the x-axis. So our x-axis, once again, just to remind you, is our horizontal line. And we want to reflect it over the horizontal line. So when we do that, we want it to be equidistant. The new image, M prime, should be equidistant from the line of reflection. So whatever is here, we need to go the same distance to the other side. So if I make that green, that will be equidistant. That will be equidistant because that is 1 up, that is 1 over. And then this is 1, 2, 3, 4 up. That should be 1, 2, 3, 4 down. So if we draw that picture, the new picture of M prime is then a reflection over the x-axis. It is equidistant over the x-axis. Another way that you can think about this is if you're reflecting over the x-axis, you're just changing your y-coordinates. So if I put in y-coordinates here, the coordinates for this is -2, +1. This is 2, 4, and this is 2, 1. Our y's change when we reflect over the x-axis. The y's become what is positive becomes negative, what's negative becomes positive. So this is actually 2, -1. This is 2, -1, and this is 2, -4. Okay, so let's try a different one. Let's do the same shape, but we want to reflect it over the y-axis. So I'm going to put my coordinates for the original triangle here. We want to reflect this triangle over our y-axis. Our y-axis, once again, is the line that goes up and down. Whatever is, we want to flip it over just like it will a reflection. So whatever is on one side should match exactly on the other side, like so, over the y-axis. And like how when we flip it over the x-axis, the y's change. Now we flip over the y-axis, the x's change. So whatever was positive becomes negative. Whatever was negative becomes positive. Let's try one more example here. What if we had that exact same triangle and we want to flip it over something different, like arbitrary? So what if we want to reflect it over a different line? Let's say we want to reflect it over this line. Make that red. This line of y equals -1. Well, it has to be equidistant from the line of reflection. So here, this is 2. So this one should be 2 down, and 2 down, and then down. So there, our new image from M to M prime is equidistant. Let's go into the last concept of symmetry. Let's think about a shape to see if a shape has symmetry. So I'm going to try my best to draw a star here. Not the best star, but a star. A star has a line of symmetry. So a normal star, if you were to draw a up and down line, one side of the star should match the other side. You should be able to fold it exactly in half. However, other shapes, don't necessarily have a line of symmetry. So let's think about like a right triangle. A right triangle with a corner here. There isn't a line that you can draw to make this triangle fold exactly in half. So this does have symmetry. Our right triangle does not have symmetry.